on Fascinating Frontiers, episode 137, coming to you on July 20th, 2026. New week, new discoveries. Let's see what's happening. 50 years after Viking 1 touched down on Mars, new missions are shifting focus from the surface to the thin air above the red planet. NASA's Viking 1 mission achieved the first successful landing on Mars on July 20th, 1976, returning the initial surface images from another planet. The lander operated for over 6 years and transmitted data on Martian soil and weather. Today, the focus has moved upward, with NASA planning atmospheric studies that build directly on that early success. The shift tests instruments designed to measure winds, dust, and trace gases at higher altitudes than previous surface missions reached. Watch for upcoming orbiter data releases that will compare current atmospheric conditions to Viking-era measurements. Now shifting to the next major crewed step beyond low Earth orbit. Artemis 3 will coordinate 4 astronauts across 3 separate spacecraft over a planned 2-week orbital stay. The mission requires precise rendezvous timing between Orion, a lunar lander, and supporting logistics vehicles. This level of integration exceeds any prior NASA crewed flight in the number of moving parts and real-time decision points. The added complexity directly advances the tracked Artemis program by testing the full stack needed for sustained lunar operations. Next milestone is hardware integration testing scheduled for later this year. On a different note, SpaceX has moved the target date for the 13th integrated flight test to as early as Thursday, July 23, with a 90-minute window opening at 5:45 p.m. CT from Starbase. The vehicle remains in final checkout after earlier scrub decisions. This update continues the steady cadence of test flights that the Starship and Mars program has followed since last week's coverage. Rapid iteration on heat shield performance and booster catch attempts remains the key open question. Observers will watch the upcoming static fire and rollout sequence for any last-minute changes. A Falcon 9 carrying 24 Starlink satellites aborted at the final moment during an attempted liftoff from Vandenberg Space Force Base. The vehicle and payload stayed safe on the pad with no damage reported. This marks the second consecutive last-second hold for the booster fleet in under 24 hours. Engineers are reviewing telemetry to isolate the trigger before the next attempt. The incident highlights ongoing work to maintain high launch cadence in the commercial spaceflight program. Subramanian Chandrasekhar calculated as a teenager that white dwarfs cannot exceed roughly 1.4 solar masses before collapsing. His insight came during an ocean voyage and relied on combining quantum mechanics with relativity in a way contemporaries had overlooked. The limit still defines the boundary between white dwarfs and neutron stars today. Follow-up papers continue to refine the exact mass threshold using new observations of binary systems. The Chandrasekhar limit story stands out because it connects a single teenager's ocean voyage calculation to the fate of entire stars. His work showed that electron degeneracy pressure can support a white dwarf only up to 1.4 solar masses. Beyond that threshold, collapse to a neutron star or black hole becomes inevitable. Modern observations of type Ia supernovae still rely on this boundary to standardize cosmic distance measurements. What remains unclear is exactly how rotation or magnetic fields might nudge the practical limit in real stars. If you pack the mass of our entire sun into a sphere the size of Earth, the material would become so compressed that normal atomic structure collapses. Electrons are forced into the lowest available energy states, creating a pressure that no longer depends on temperature. In a white dwarf, this electron degeneracy supports the star against gravity even after nuclear fusion has ceased. The process operates at densities around 1,000,000 times greater than water, with surface temperatures that can still exceed 100,000 Kelvin shortly after formation. Yet the same physics sets a hard ceiling. Once the mass climbs past 1.4 solar masses, the electrons can no longer resist and the core implodes. We can calculate that threshold precisely, but we still do not fully understand how rotation or strong magnetic fields in real stars might shift the practical boundary by a few percent. The magic magnetometer aboard the Henon CubeSat will sit in deep space to give up to 3 hours of advance notice for solar storms instead of the current 15 minutes. The instrument measures magnetic field changes carried by the solar wind before they reach Earth. Launch is planned for early 2027 as part of ESA's Planetary Defense Initiative. Data will feed directly into space weather models used by satellite operators and power grids. Researchers applied machine learning techniques to large datasets from multiple observatories to characterize an exoplanet atmosphere in greater detail than previous methods allowed. The approach combined transit spectroscopy with orbital dynamics to separate planetary signals from stellar noise. Results improve constraints on atmospheric composition and temperature structure. Further papers using the same pipeline are expected once additional JWST cycles are processed. A compact 10-ray imaging system has captured its initial data from orbit, demonstrating a new tool for monitoring astronaut bone density and radiation exposure in real time. The device uses low-power detectors that fit within existing crew quarters constraints. Early images confirm the hardware survived launch and operates as designed. Expanded use on future long-duration flights is now under review. High-resolution images show scattered debris left by a massive dust storm that swept across the planet long ago. The patterns include wind-blown ridges and isolated rock piles that have remained largely unchanged since the event. Orbital instruments map the deposits to reconstruct wind directions at the time. Continued imaging will track any new changes from recent storms. A new study documents the steep decline in cost per kilogram to orbit over 6 decades, driven mainly by reusability and higher flight rates. Projections suggest another comparable drop could occur by 2040 if current trends hold. The analysis draws on historical records from government and commercial providers. Lower costs directly support more frequent robotic and crewed missions across multiple programs. The lunar phase visible tonight repeats the exact appearance from July 20th, 1969, thanks to the 19-year metonic cycle. Observers can compare current views with historical photos taken during the first crewed landing. The alignment offers a direct visual link across more than 5 decades of lunar exploration. International discussions on July 20th emphasized growing amounts of orbital debris and the need for coordinated removal efforts. Participants reviewed current tracking capabilities and proposed new guidelines for end-of-life satellite disposal. The session tied debris mitigation directly to long-term sustainability of lunar and cislunar operations. The UN event highlighted risks to satellites and future lunar infrastructure. Coordinated removal efforts were presented as necessary to protect expanding operations. Tracking capabilities were assessed against the increasing volume of debris already in orbit. NASA Langley engineers led key elements of the Viking lander design, including entry, descent, and landing systems that succeeded on the first attempt. Their work established techniques still referenced in current Mars missions. Archival documents released for the anniversary detail the iterative testing that reduced risk for the 1976 landings. Serpens is the only constellation divided into 2 non-contiguous parts, with Ophiuchus separating the head from the tail. Caput covers more area and contains several binocular-friendly star clusters. Summer evenings place both sections well-positioned for Northern Hemisphere viewers. The article reviews the most notable comets of the century so far, including their orbital paths and peak brightnesses as seen from Earth. Nucleus sizes generally stay under 10 kilometers, yet they produce extended tails when heated by the sun. Observers can use the provided finder charts for any returning objects this season. Before we go, keep an eye on the next Starship static fire test for any updates on the booster catch sequence. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. This show comes to you from the NERA Network. If you want another sharp daily briefing, Environmental Intelligence has you covered. The Environment and Climate Policy Brief for Canada. All our shows are free at naranetwork.com. The Do Positive Pod is the club for people who do something about it. Episodes and the dispatch wall at naranetwork.com/thedppod. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly